What if you could only see one color? Imagine, for instance, that you could only see things that were red, and that everything else was completely invisible to you. As it turns out, that's how you live your life all the time, because your eyes can only see a minuscule part of the full spectrum of light. Different kinds of light are all around you every day, but are invisible to the human eye. From the radio waves that carry your favorite songs, to the X-rays doctors use to see inside of you, to the microwaves that heat up your food. In order to understand how these can all be light, we'll need to know a thing or two about what light is. Light is electromagnetic radiation that acts like both a wave and a particle. Light waves are kind of like waves on the ocean. There are big waves and small waves, waves that crash on the shore one right after the other, and waves that only roll in every so often. The size of a wave is called its wavelength, and how often it comes by is called its frequency. Imagine being a boat in that ocean, bobbing up and down as the waves go by. If the waves that day have long wavelengths, they'll make you bob only so often, or at a low frequency. If the waves instead have short wavelengths, they'll be close together and you'll bob up and down much more often, at a high frequency. Different kinds of light are all waves, they just have different wavelengths and frequencies. If you know the wavelength or frequency of a wave of light, you can also figure out its energy. Long wavelengths have low energies, while short wavelengths have high energies. It's easy to remember if you think about being in that boat. If you were out sailing on a day with short, choppy waves, you'd probably be pretty high energy yourself, running around to keep things from falling over. But on a long wavelength sea, you'd be rolling along, relaxed, low energy. The energy of light tells us how it will interact with matter, for example, the cells of our eyes. When we see, it's because the energy of light stimulates a receptor in our eye called the retina. Our retina are only sensitive to light with a very small range in energy, and so we call that range of light visible light. Inside our retina are special receptors called rods and cones. The rods measure brightness, so we know how much light there is. The cones are in charge of what color of light we see, because different cones are sensitive to different energies of light. Some cones are more excited by light that is long wavelength and low energy, and other cones are more excited by short wavelength, high energy light. When light hits our eye, the relative amount of energy each cone measures signals our brain to perceive colors. The rainbow we perceive is actually visible light in order of its energy. At one side of the rainbow is low energy light, we see as red, and at the other side is high energy light we see as blue. If light shines on us that has an energy our retina can't measure, we won't be able to see it. Light that is too short wavelength or high energy gets absorbed by the eye's surface before it can even get to the retina, and light that is too long wavelength doesn't have enough energy to stimulate our retina at all. The only thing that makes one kind of light different from another is its wavelength. Radio waves have long wavelengths, while X-rays have short wavelengths, and visible light, the kind you can actually see, is somewhere in between. Even though our eyes can't detect light outside of the visible range, we can build special detectors that are stimulated by these other wavelengths of light, kind of like digital eyes. With these devices, we can measure the light that is there, even though we can't see it ourselves. So take a step back and think about all of this for a moment. Even though they seem different, the warmth you feel from a crackling fire is the same as the sun shining on you on a beautiful day. The same as ultraviolet light you put on sunscreen to protect yourself from. The same thing as your TV, your radio, and your microwave. Now those examples are all things here on Earth, things you experience in your everyday life. But here's something even more amazing. Our universe gives off the full spectrum of light too. When you think of the night sky, you probably think of being able to see the stars shining with your own eyes. But that's just visible light, which you now know is only a tiny part of the full spectrum. If we had to draw the universe and could only use visible light, it'd be like having only one crayon. Pretty sad. To see the universe in its full spectrum, we need to have the right eyes, and that means using special telescopes that can help us see beyond visible light. You've probably heard of the Hubble Space Telescope and seen its beautiful pictures taken in visible and ultraviolet light. But you might not know that there are almost 20 space telescopes in orbit, missions that can each see part of the full spectrum of light. With telescopes acting as our virtual eyes, both in space and here on Earth, we can see some amazing things. And the coolest thing of all? No matter the wavelength or energy, the light that we see out in the distant universe is the same thing as the light that we can experience and study here on Earth. So since we know the physics of how X-ray, ultraviolet light, or microwaves work here, we can study the light of a distant star or galaxy and know what kinds of things are happening there too. So as you go about your daily life, think beyond what your eyes can and can't see. Knowing just a little bit about the natural world can help you perceive the full spectrum around you all the time.